Welcome to section 2.3, and what really happens here is we get into the actual definition of a limit. Now, as a student, this was by far my least favorite section, so I'm being brutally honest here, but please realize that it's just a matter of understanding what each of these things means and how we can use them to solve problems. Now, a lot of times I do complain about the fact that graphs generally aren't very accurate and I don't like them. But here, doing a graph actually will help us to understand several things. But basically we need to look at the definition of a limit is there is some item called delta that is greater than 0. In other words, delta is just some positive number. Generally, it's a very small number, and such that if we have this situation occur, if the absolute value of x minus x sub 0 is less than delta, then that implies that the absolute value of f of x minus L is less than some value called epsilon. Now that looks like a funny backwards 3 or a sideways W or whatever, but that is a Greek letter epsilon. And basically what we need to do is we just need to decipher a lot of these things. First thing is the fact that most of the time we are looking for delta. We are looking for some particular value. Now, what some of these things would represent would be things such as this. We let x sub 0 is in essence, whenever we see limit as x approaches, say 3, x sub 0 would be 3. It's whatever we're actually striving towards. That's what x sub 0 is. The x value here would be some value of x close to the limit. And in particular, what it is it's going to either be, we're going to take x sub 0, which is the limit that we're trying to go towards, and it's either going to be add or subtract delta. Okay, and delta generally is a small number, so we'll either add it to the x value will actually be x sub 0 plus delta or x sub 0 minus delta, and then oftentimes you have to do both of them. Okay, now what happens here is f of x should be plain and simple. That is the function that we are talking about. L, it actually makes sense. L is actually the limit when x approaches whatever number. In this case I've been using 3, but it can be any number. It can be 5, it can be 16, whatever. And then epsilon is just a number that shows the difference in the y's. Delta is very much the difference in x's. Epsilon is the difference in y. And so if we know those things, and this is probably the most notes you'll get out of me the entire semester, is you need to understand each of those parts and then look at a graph and pretty much it all fills in. Okay, so we look at examples 1 and 2. We're going to use the graph and we're going to find a delta that is greater than 0. In other words, a positive delta such that for all x, this situation right up here is true. Now, in order to do that, if we look at number 1, well, that's a long pause. Okay, for number 1, we are told f of x equals negative 5x minus 2. We are told x sub 0 equals negative 1, L equals 3, and epsilon equals 0.2. Now this shouldn't be too terribly difficult looking at what we've been told. We're told the limit is 3 when x approaches negative 1. Well, if we plug in negative 1 here, negative 5 times negative 1 is 5. 5 minus 2 is 3. So the limit does equal 3. But now we look, how does this 0.2 play in? Well, epsilon is the difference in the y values. And remember, the limit is the y value. So if we look at the graph, we have 3 over here. And then we can add 0.2 to that, and we get 3.2. Or we can subtract 0.2 from that and get 2.8. Now, a lot of times when we do graphs, we look at the x value and that determines the y value. What we're really interested in now is we're looking at the y values and see what are the corresponding x values. So if we go to the graph, the 3 matches up with 1, and that shouldn't, or I'm sorry, negative 1. That shouldn't be a big surprise because when x equals negative 1, y would equal 3. Here when we get 2.8, the value is negative 0.96, and when we're here at 3.2, the x value is negative 1.04. Now we are trying to find delta. Delta is the difference in the x's. So, but there's 2 potential different answers, and so we're going to have to determine which one is it. Okay, the first one we're going to do is figure out what is the distance between here and here. So, negative 1.04 minus the negative 1, and we're going to take the absolute value because that's how we can find the distance of a linear measure. And this becomes the absolute value of negative 0.04. Absolute value is 0.04. So that's the difference there, or that would be a potential delta. We'll call this delta sub 1. Now we have to find the difference between those two, and we're going to do it in exactly the same way. Negative 1 minus a negative 0.96 absolute value will equal the absolute value of negative 0.04, which equals 0.04, and we'll just call that delta sub 2. There's no reason to call these delta sub 1, delta sub 2, except for it's easier for me to just explain it rather than having to try and point to it on these notes. Now, we're almost done. We've done the hard part. We've already determined that the difference in the x's, the 2 potential different deltas, are 0.04 and 0.04. And so what we need to do is we need to come up with a delta that is greater than 0 such that for all x's, well, basically what that means is we need to pick the biggest delta. Well, between these two, they are both the same. So our final answer, delta, would equal 0.04. Now sometimes these are different depending on the function. And so, but since they're both the same, our delta is 0.04. If they were different, we would take the one that was bigger, and that would be our delta. So final answer is delta is equal to 0.04. Example number 2 is just pretty much the exact same stuff, just different functions and stuff like that. Once again, look at the drawing and use what's there. So number 2, f of x equals 2 root x. X sub 0 is equal to 3, so we're going to be approaching 3. The limit is not too difficult to calculate. That is 2 root 3. That shouldn't be a big surprise. And we're going to let epsilon equal 1/4. Okay, now, the first thing we do in this, according to the diagram, we need to find some epsilons. Okay, well, we know epsilon is 1/4, or actually 0.25 as the graph shows. Now my question is, where did the 3.46, whenever we let x equal 3, where'd the 3.46 come from? Well, plain and simply, that's what 2 times the square root of 3 is as a decimal equivalent. So we have 3.46. Now, epsilon, which is going to be the difference in these, is 1/4. So we can subtract out 0.25 and get 3.21. Or we can add 0.25 to that and get 3.71. And that's where those numbers come from. Just realize from here to here is epsilon, and from here to here is epsilon as well. The change in the y's. Now we need to go and look at these values here. Once again, the scale is totally irrelevant. Now this right here is 3, because that is x sub 0. Now the question becomes how, or we're told this is 2.5831 and this is 3.4481. Now realize the next problems we're going to figure out how can we determine those answers, but all we want to do is find deltas. So the first thing we're going to do is find out what's that difference right there. So it'll be 3 minus 2.5831, the absolute value, and the absolute value of all that equals 0.4169. So we'll just let this be delta sub 1. Okay, now we have to find this difference here. So that would be 3.4481 minus 3, which equals 0.4481, and that will be delta sub 2. But we need a delta such that all of them fall into this category. So what we have to do is we have to pick the biggest one. The delta would be 0.4481, because 0.4481 makes sure that that's the absolute biggest difference between the two, because it's just as big as the biggest one, and it's bigger than the first one right here. So see, the 0.4481 will cover both the 0.4481 and the 0.4169. We'll pick up video 2, how do we determine these values, right here.